Welcome to this section of the Algebra word problem tutor, where we're going to have word problems that deal with speed and distance and time. These kinds of problems are the ones that I know you've all seen before, where you'll have train A leaves a station at this time and train B leaves a station at this time, and they're going at a certain speed, and how long does it take them to reach, or how long does it take them to overtake one another, or whatever. There's lots of different variations on this kind of problem, but they all involve distance somehow and speed and time. Okay. Now, one thing I want to point out before we really get into the actual word problems is that distance, speed, and time, they're all interrelated. Okay. Let me ask you a question. When you're going down the road and you're obeying the speed limit, okay, how fast are you going? Okay. We say that you're going 55 miles an hour or 60 miles an hour. Now think about that for a second. 60 miles per hour, okay? That means every hour that clocks along, I've gone 60 more miles. Another hour goes along, 60 more miles. Another hour goes along, 60 more miles. So that tells you right there that distance, speed, and time are all interrelated, okay? The speed is 60 miles an hour, the unit, miles per hour, okay? And what that means is 60 miles, which is the distance, and 1 hour, which is the time. So distance, speed, and time, they're all interrelated, and they're interrelated by this following equation. Speed is equal to the distance traveled divided by the time, okay? And this is, you don't even really have to remember this. Just think about your car. When you're going 60 miles an hour, you're going 60, this would be miles, and this would be hours. And the division means per. So when you say 30 miles per hour, or when you're going down and you want to buy a car and it tells you this car gets 28 miles per gallon, that means divided by miles per gallon. Miles, that many miles per gallon of gasoline that you burn. In this case, it's distance over time, miles per hour. It could also be meters per second. It could be miles per second. It can be football fields per day. It could be whatever, as long as it's distance and time on the bottom. That's a unit of speed, okay? Now, one thing I want to tell you is this is the equation for speed, the relation of speed, okay? Now, a lot of times in these problems you'll be dealing with, you'll have to deal with the speed, but you'll also want to deal with the distance, and I'm not going to tell you why now because it'll just confuse you. We'll just work some problems. But if you needed to deal with distance, you could just solve this equation. This is an equation like anything else. If you want to solve for distance, you can do that. If you want to solve for time, you can do that. So if you wanted to solve for distance, how would you do that? Well, if I wanted to solve for distance, I'd have to get rid of this time, just like if it were any old equation. So I'd multiply both sides of this equation by time. It would cancel on this side, time on the bottom and time on the top. Time divided by time gives you 1. But over here I'd have speed times time. Okay, so distance is speed times time. I mean, this isn't rocket science here, okay? If you know that you're going 60 miles an hour, okay, and you know that you're traveling for 3 hours, then you know that you must multiply those numbers together. 60 miles per hour, traveling for 3 hours. I must multiply those together. 6 times 3, 180 miles traveled, okay? But in equation form, it's distance is equal to speed times time, okay? And I'll give you one aside that's very helpful as you solve these problems and other problems. The units of speed is let's just say miles per hour. Okay, and if you multiply by the time, which is in hours, okay, you see what's happening here. If you look at the units, if you've got miles per hour times hours, the hours, this is just like any other variable. Hours can cancel with hours. You have hours on the top, hours on the bottom. It leaves you with distance, okay? So miles per hour times hours, which is what we're saying here, is equal to distance. And the units work out too. Miles per hour times hours, hours cancel, leave you with distance. That's really why it works, okay? So I'm going to leave this on the board, okay, because we're going to use it. Let's go ahead and work our first problem. These problems are going to get, they're going to sound confusing at first, okay? I'll just be honest with you. You need to just read every sentence and make sure you understand every sentence and try to translate it to the algebra. 2 planes leave an airport and fly in opposite directions. Okay, one plane flies at 125 miles per hour. And the other plane flies at 75 miles per hour. How long will it take them to be 500 miles apart? Okay, so here's an airport. right where my finger is. One airplane goes this way, one airplane goes this way, and they go at different speeds, okay? One going at 125 miles an hour, one going at 75 miles an hour. And the question is, how long does it take, so how many hours does it take for them to be a certain distance apart, 500 miles apart? So let's draw a picture. Here's your runway for your airport, okay? And you have plane A, which goes this way, okay? And plane A flies at 125 miles per hour, okay? And plane B goes the opposite direction from the airport at 75 miles an hour. Okay, now notice the problem doesn't really talk too much about the speeds, other than it tells you what they are. What the problem's asking you is asking you how long. How long does it take for something to happen? How long does it take for them to get so far apart? How long? So you have to start thinking in terms of time, okay? How long will it take them to travel so far apart, okay? All right, so what we want to do is we want to figure out how long it takes them to travel this far. So we know we're going to involve time, okay? We know we're going to involve time, and we want to write an equation that involves how far apart they've traveled, okay? Because it says right here in the very last sentence, how long will it take to be 500 miles apart? So they're going to be 500 miles apart, okay? So, logically thinking, after some amount of time, this plane will travel so far this way, and at the same amount of time, this plane will be so far this way, okay? The sum of these two things, the sum of these two distances the planes travel, when they equal 500 miles, that's when we stop the stopwatch and we say, okay, that's long enough. That's what we're trying to find, okay? So the distance that this plane travels is going to be 125 times the time traveled, okay? Now think about that for a second. That's why I put this up here. Distance is speed times time, right? The distance this plane travels, this is the distance plane A travels in time t, which we don't know. That's what we're trying to solve for. How long does it take? Okay, but we know that after a certain number of hours, this plane will travel this far, 125 times t, speed times time. Okay, plus how long does this one travel? How far does this one travel? 75 times t. In the same amount of time, it travels less because it's going slower, but it still travels 75 t. When you add these up, whenever they equal 500, that's as far as we want to go, because it says how long does it take to be 500 miles apart. This is the distance B travels in time t. Okay, that is the hardest part of the whole thing, just figuring out what to write down. Now, solving it's pretty easy. 75 plus 125 gives you 200. T is equal to 500. So t, which is the time, is 500 divided by 200. Okay, and that's equal to 5 halves. Okay, so t is equal to 2.5 hours. 2.5 hours. Okay. So again, recapping. You have an airport, plane going this way, plane going this way. The distance this plane travels in some time that we don't know the answer to yet is 125 times t, because distance is speed times time. Speed times time, okay? That's how far he travels. This plane travels a certain distance in the same time. When you add them together, eventually they'll be 500 miles apart. That's when we want to stop everything and solve for t at that point. And then solving for t is just a simple matter of the algebra. And if you wanted to solve this, it wouldn't be terribly hard. You would take, okay, we said the answer was 2.5, right? So how far would you go? You would turn it right back around and put it into this equation. 125 times 2.5 plus 75 times 2.5. And you would try to figure out if this equals 500, and it does equal 500. When you put this in your calculator, you get a number here and a number here. You add them up, you're going to get 500 miles. Okay? So, no different than before. You just have to really take your time and make sure you know what you're writing down in your equations. Second one's a little bit more difficult. We're going to get a little bit more difficult, but we're always going to be using the distance and the time formulas here. Okay? Okay, two people leave from two towns that are 200 miles apart at the same time and they travel along the same road toward each other, a person A drives 10 miles an hour slower than person B. If they meet in 2 hours, at what speed did they travel? Okay, this is a great example of a lot of words and a lot of numbers in a problem. And this is the kind of thing you'll read on a test and you'll try to figure it out, without using any math. And you'll draw a lot of people just try to do it without really mathematically doing it. They just try to start working it and guessing, okay? You need to not do that with these problems. You need to translate the sentences into algebra and go through it, okay? So we'll read it one more time. 2 people leave from 2 towns. So there's a town over here and there's a town over here. 2 people leave. This one comes this way, this one comes this way, okay? Travel toward each other, same road. Person A drives 10 miles an hour slower than person B. So this one's going faster, this one's going slower, okay? And they meet in 2 hours. It takes them 2 hours to meet. That's important. What speed did they travel? Okay, what speed did they travel? So we're going to have to find that out. So we have 2 equations and 2 unknowns because we know we're going to have to find the speed of person A and the speed of person B. Okay, so let's say you have a road here and you have person A going this way and you have person B going this way. Okay, you know that this road is 200 miles long. Okay, because it tells you the two things are 200 miles apart. Okay, so my variables are going to be speed of A is speed of A. S sub A just means speed of A of person A, and S with a little b is the speed of B. Don't get scared by these little B's and A's. I mean, they're just notation. It's something you write down to remind you this is the speed of person A and the speed of person B. That's all it's saying. Okay? And now the next step is to write some equations down that relate these things to each other from the words in the problem and go from there. Okay? So, reading the problem again. 2 people leave, 200 miles apart. Okay, got that. Travel along the same road. If person A drives 10 miles slower than person B, okay, that's the first thing. Okay? Person A drives 10 miles slower than person B. That's pretty easy to understand. Person A drives 10 miles slower than person B. Person B, subtract 10, gives you the speed of A. Okay? Now the next one is the one that's a little bit harder to translate. Okay? If they meet in 2 hours, at what speed did they travel? Okay? If they meet in 2 hours, at what speed did they travel? Well, what you need to do is you need to write an equation down like this. Let's go ahead and work on this first. We know from before, and I'm going to write it down over here, that distance is speed times time. Speed times time. We've already established that from before. Okay, so we're going to use that. We know that they're 200 miles apart. Okay, so if speed of person A times time plus the speed of person B times time. This is the distance person A traveled going this way, and this is the distance person B traveled going the other way. When the total of those two things add up to 200 miles traveled, then they have by definition met in the middle. These are the kinds of things you'll have to get the hang of translating in your problems, okay? When they meet, okay, that means the total distance has been traversed. The distance has been traveled. The 200 miles has been traveled. So the distance person A goes this way, plus the distance person B goes this way. When they add up to 200, then they have met, okay? Now, we know what the time is, okay? Because it tells us that the time is 2 hours. So this turns into SA times 2 plus SB times 2 is equal to 200. And you could have started out with this and written that down because you're given that in the problem, but I wanted to show you here where it was coming from. So here's an important equation, here's an important equation. 2 equations, 2 unknowns, and you can solve the problem, okay? Here we know the difference in the speeds, and here we know that they met in the middle after 2 hours. This guy traveled so far in 2 hours, this guy traveled so far in 2 hours, and when they finally add up together, that means they met in the middle. So let's take this equation and put it into that one. SB minus 10 times 2 plus SB times 2 is equal to 200. Okay? Just taking this, put it into SA right here. SB minus 10, that's all I've done. Now let's multiply this 2. 2SB minus 20 plus 2SB is equal to 200. Okay? 2 times SB is SB, 2SB. 2 times negative 10 is negative 20. Now let's add these SB's together. 4SB minus 20 is equal to 200. Okay, let's move this 20 over here. 4SB is equal to 200 plus 20. All you do is you're adding 20 to both sides. 4SB is equal to 220. Okay? And then to solve for B, for SB, is equal to 220 divided by 4. So SB is going to be equal to 55 miles per hour. Okay? Okay, so we've solved for one of the two speeds. The person B's speed is 55 miles an hour, and to find the speed of the other person, you just plug it back into one of your other equations, so I'm going to use this one. SA is equal to SB minus 10. Okay, so the next thing we're going to do is take this and plug it in. So SA is equal to 55 minus 10. So SA is equal to 45 miles per hour. So it's the same thing that we've been doing before. You have to draw a picture usually to help you out here. You write down the first equation. That wasn't pretty easy, talking about the difference in the speeds. You write down the second one. This one's the harder one to write, but you're dealing with distance here. You know they must meet in the middle, so you know they must travel 200 miles. You know how far one guy travels. You know how far the other guy travels. This is speed times time, always gives you distance. And when you add them together, it must equal 200. So that's your other equation. From then it just becomes algebra, plugging one into the other and substituting back in to find the other speed there. And you could check your work by just taking these two speeds and plugging them back into these equations and making sure that they add up, and they will add up. If you take 55 times 2 hours and you take the 45 times 2 hours and you add them up, you'll find out that they travel 200 miles total. Okay, the next problem. Two people walk in opposite directions. If they leave at the same time and one person walks twice as fast as the other, and in 2 hours they're 10.5 miles apart, what are their walking speeds? So two people start at the same point, they walk different directions, they have different speeds. We're going to find two different speeds in this problem, okay? They leave at the same time, one person walks twice as fast as the other, 2 hours, they're 10.5 miles apart. How fast were they walking? Okay, so let's draw a picture. They start here, you've got happy person A, and you've got happy person B, okay? And one guy goes this way, A goes this way, and B goes this way. And you don't know how fast they're going. That's what you're trying to find, okay? So we're going to call his speed SA, we're going to call his speed B. Okay, now the first thing is, looking at the problem, the first sentence, or the second sentence, if they leave at the same time and one person walks twice as fast as the other, then that just simply means that one person, if you pick A, is going twice as fast as the other one. So my S is the speed. 2 times the speed of B is equal to the speed of person A. So one person's going twice as fast as the other. That's all that that's saying, okay? Now, we know they start at one point and they move out. We know that after a certain amount of time, he's going to go a certain distance, and we know at a certain amount of time, he's going to go a certain distance. But all we know is that after 2 hours, they're 10.5 miles apart. Okay? After 2 hours, they're 10.5 miles apart. So what we want to write an equation for is how far they've walked, okay, in a certain amount of time. Okay? So the distance he's walked and the distance he's walked individually, you add them together, and after they equal 10.5 miles, that's what we're going to try to do here. So let's go ahead and write it down. The speed of person A, okay, times 2, okay, because, and I'll talk about this in a second, but the speed of person A times the 2 hours you're talking about, okay, plus the speed of person B times 2 hours, okay, is got to be equal to 10.5. This is the second equation. Okay, this is the second equation, and you need to make sure you understand this. SA times 2 is a speed times time. That's the distance. This is the distance person A travels, okay? This is the distance person A travels in 2 hours. This is the distance person B travels in 2 hours. I do not know the speeds in which they've traveled. That's what I'm trying to solve for. but I know that once I add the two distances up that they've walked, it must equal 10.5 miles. So I've translated that second sentence. Just read it again. If one person walks twice as fast as the other, okay, here's where we start. And in 2 hours, they are 10.5 miles apart. That means that how far this guy walked plus how far this guy walked must equal 10.5 miles. Then what are their speeds? Now notice I've got two equations and two unknowns, so I can solve for these speeds. Okay? So I'm going to take SA and I'm going to plug it into here. So I'm going to have 2SB times 2 plus 2SB is equal to 10.5. Okay? Just take this and plug it in there. That's all I did. So you have 4SB plus 2SB is equal to 10.5. And you just add these up, so that's 6SB is equal to 10.5. So SB is equal to 10.5 divided by 6. SB is going to equal 1.75 miles per hour. Okay, so we found one of the speeds, 1.75 miles an hour. And then to find the other one, you just take this and you just plug it back in here to find your other one. So SA is equal to 2 times SB. SA is equal to 2 times SB, 2 times 1.75. So then SA is going to equal 3.5 miles per hour. Okay, so again, the math behind it, solving the two equations, is very simple. The hard part is actually writing down the equation. So let's recap it one more time. Person A travels twice as fast as person B. That's the first part of the problem. Second part of the problem is talking about how long they have traveled, that's the time, and how far they have traveled. And each person individually in the 2 hour time has gone their speed times the time. That's how far they've gone. Distance is speed times time. Distance is speed times time. You add the two distances up that these two people have traveled. When they equal 10.5 miles, that's your equation. So that's what you're trying to write down here. There's really no way to teach this other than working problems, okay? So as we work these problems, if you're feeling frustrated because maybe you didn't think of this right away, that maybe you didn't think about writing it down this way, and you're thinking, I'm never going to get this. Don't feel like that. Everybody has gone through that, okay? Nobody is born knowing how to write algebra equations and word problems, okay? That's why we're doing these things. You get practice and you work enough of them and you kind of see and think about how to write them down. And you learn by doing and you learn by examples. So if you have to watch this section more than once, that's normal, okay? That's very normal. I had to do that for sure when I started out. Okay, next problem. You ride a bicycle to a friend's house at a speed of 8 miles an hour. So you're here, friend's house is over here, you're going 8 miles an hour to a friend's house, okay? When you walk home, and then once you get to your friend's house, you turn around and you walk home, you at the speed of 2 miles an hour, which is slower than the bike, obviously. The total round trip time is 1.25 hours. How far was your friend's house? Okay, so it's best just to start out by drawing a picture, okay? Here is your friend's house. Okay, first thing you do is you get on a bike. I'm a terrible artist. That's a bike. Okay, and you're going this way towards your friend's house. Okay, and you're going at 8 miles an hour. Okay, and then when you get here, you walk back. Okay, and you're walking back this way. Let's do it like this. You're walking back this way, and you're walking back at 2 miles an hour. Okay, you're walking back at 2 miles an hour. Okay, now the question says you ride a bike to your friend's house at 8 miles an hour, you walk back at 2 miles an hour. Okay, total round trip time is 1.25 hours. How far was your friend's house? How far was your friend's house? Okay, well the first thing you want to remember is that speed is equal to distance over time. We talked about that, miles per hour. Okay, so we've already talked about the fact that distance is equal to speed times time. We've used this one in all the problems so far. Okay, now one more thing I want to show you is you can solve this equation for time. Time is just going to equal the distance over speed. Time is distance over speed. That's just solving this for dividing both sides by speed. Time is distance divided by speed. That's going to be important for this problem, and you'll see why in a second. Okay, The fundamental thing to think about here for this problem is you get on your bike, you drive to your friend's house, then you get off your bike and you walk back and you're going 2 different speeds. The fundamental thing to think about is the total round trip time is 1.25 hours. That's crucial because that's telling you, just like the distance in the other problems was kind of constraining things. It was like the other problems with the 2 people walking apart and finally they get so many miles apart, and that's telling you that you're writing an equation in terms of distance because they get so far apart. In this problem, I'm driving at a certain speed, I'm walking at a different speed. Okay, the constraint, or the thing that ties it all together, okay, is that the total round trip time is 1.25 hours. That's important because it tells me that I'm going to be dealing with time, okay? This is how long it takes the entire thing to happen, okay? So, writing it down, the time of the walking, let me write it this way. The time that I was on the bike plus the time that I spent walking is equal to 1.25 hours. That's very, very important. This is very, very important, and that's why I'm writing it down this way. That is the major constraint in this problem. The time I spend on this bike plus the time I spend walking back is 1.25. That is one equation, okay? So, I've already shown you that the time is equal to the distance divided by the speed, okay? So if I'm going 3 miles an hour and I'm on my bike for 3 minutes, I divide them, and I can tell you, or if I'm on my bike for 37 miles and going at 3 miles an hour and I divide them, they'll tell you how long it takes me to do that, okay? So we're going to use these 2 facts, okay, and we're going to write our equation like this. The time on the bike, okay, is equal to the distance, okay, that I traveled divided by 8 miles an hour, because the speed was 8 miles an hour, plus the distance here divided by the speed that I walked, which was 2, gives me that there. That's going to equal 1.25. You have to make sure you understand this, or nothing else that follows will make sense at all. The time that I spent on this bike plus the time that I spent walking back was equal to 1.25 hours. But I know that the time on the bike is equal to the distance, okay, divided by the speed that I traveled, that I was traveling at, okay? And I know that the time I spent walking is equal to the distance that I walked divided by the speed that I was on. Don't forget, this distance is the same. The distance I drove to the house is the same as the distance that I came back with. So distance is what I'm trying to find, because the very last sentence is, how far was your friend's house? This is how you're solving it. You know that the time, the total round trip time must be 1.25 hours, and you know that each time can be written in terms of the distance you traveled, which is what I'm trying to find, divided by your speed. Distance I traveled on my walking divided by my speed. The sum of these 2 things must be equal to the 1.25 hours. Okay. So after this, it's really not going to be that big of a deal. You take the d, we're going to factor out the d. 1/8 plus 1/2 is equal to 1.25. And then on the inside, it's easier just to go ahead and do this in terms of decimals. You're going to have 0.125 plus 0.5, okay, is equal to 1.25. So on the inside here, you're just going to have 0.625 is equal to 1.25. And so then the distance is just simply going to be 1.25 divided by 0.625. And so the distance is going to be 2 miles. Okay? Again, the mathematics isn't really that hard. It's really just the problem of taking the text and figuring out what to do with it. Here, we had to write an equation in time because the problem gave us a constraint in time. Just like the other problems were giving us the distance traveled, this one gave us the time. So you know you're going to be dealing with time, and you know you've got distance and time and speed, so you need to be dealing with these distance time formulas, right? You know the time on the bike plus the time walking back was equal to this, and you just wrote an equation dealing, expressing the time on the bike in terms of its distance and speed. You knew the speed, and same thing here, add them together, go through the math, and that's how you solve for the distance there. Okay, here's going to be our final one. A person leaves a house by bicycle and travels at 5 miles an hour. 1 hour later, another person leaves by car and travels down the same road at 30 miles an hour. How long does it take for the car to overtake the bicycle? So you have a house, somebody rides out on a bicycle, and to give you the speed here, it travels at 5 miles an hour. 1 hour goes by. So the bicycle travels some distance. 1 hour goes by. Then a car leaves, goes down the road at a much faster speed, 30 miles an hour. How long does it take for the car to catch up to the bicycle? Okay, that's what we're trying to do. How long does it take? How much time does it take? Okay, so what we're going to do first is we're going to draw a picture. Okay, we're going to draw a little house here. Okay, and we know that somebody's over here on a bicycle. Okay, and this bicycle is traveling this way at 5 miles per hour. Okay, and we also know that this car leaves. You can tell I'm not an artist, right? This car leaves, is going this way at 30 miles per hour, and this guy leaves 1 hour later. Okay, now the thing to remember here is it says, how long does it take for the car to overtake the bicycle? What this means is the bicycle has traveled some distance, right? And then the car leaves. And then the bicycle continues moving and the car catches up to him, right? Eventually, they overtake. And what that means is the distance that they have both traveled from the house is the same. So you have to kind of read between the lines in this problem, okay? And you have to realize that when the car overtakes the bicycle, all it really means is that at that moment, the total distance traveled between each one of these things to the house is the same, okay? So prior to the car catching up, the bike has gone farther. And then the car is catching up. Eventually, when it meets the bicycle, they've both traveled 10 miles from the house, let's say, whatever it is. Whatever the number is, it doesn't even matter. It's just that at that point, the total distance traveled between each of the things to the house is the same. That is a constraint in this equation. So you're going to be writing an equation involving distance. And those distances are going to be equal at some point from the house. And then that's your constraint. You can solve for what you're trying to solve for. Okay, so don't forget, just to remind you, that speed is distance over time, which means that distance is equal to speed times time. Okay, distance is equal to speed times time. You're going to use that. Okay, so the unknown is the time t. Let's write our equation. Okay, the speed of the bike. Okay, the speed of the bike times 1 hour. Let me write this down and then explain what's going on here. Okay, plus the speed of the bike times time traveled is equal to the speed of the car times time. Now, let me make sure you understand what's going on here. Remember, the bike left an hour ahead of time, okay? So the bike has a head start. It has traveled this much distance, speed of the bike times 1 hour, okay? This is the distance bike traveled in the first hour. So he goes down the road. He goes 50 feet down the road, whatever it is, okay? Speed times time, okay? Now, the clock starts. Car leaves, then the bike continues traveling, okay, at some distance, and the car is traveling at some distance, okay? This is distance bike travels after car leaves. Okay, and this is just the distance car travels. Okay, so bike gets a head start, goes down the road certain distance in 1 hour, okay? Bike continues gaining ground after the car leaves, and the t is the length of time that the car is on the road, right? That's when the clock starts. And then the car goes down the road at a certain speed, and so it goes a certain distance. So now we can solve this problem. Okay, so now we can solve this problem. We know what the speeds are. I just wrote this down to kind of show you conceptually what we're doing. The speed of the bike is 5. So 5 times 1 plus 5 times t is equal to, the car speed is 30 times t, okay? So don't forget what we're doing. This is the total distance traveled by the bike, and this is the total distance traveled by the car. Bike gets a little bit of a head start, so we have a little extra term here. It goes so far, and then it continues traveling after the car has left, but eventually the car catches up to it, and the total distance traveled by the car is equal to the total distance traveled by the bike. That's when it overtakes it. We know the velocities of the bikes, and we just keep our time in here. We know the velocity of the car. So what we have here is 5, and we're going to move, and let's see, 5 plus 5t is equal to 30t. Let's just do it that way, okay? And what we're going to do is we're going to say 5 is equal to, we're going to move this 5t over here, 30t minus 5t. So we'll have 5 is equal to 25t. Okay? Then finally, what we do is we divide both sides by 25 to get t by itself. So 5 divided by 25. So then t is equal to, t is equal to 1/5 of an hour. Okay, 1/5 of an hour, which is 0.2 hours. Okay? So that's the total time traveled. So, you know, it's hard to know exactly what equation to write here, but the main thing to remember is that when something overtakes something, the distance is the thing that's constrained. The distance traveled here is the same as the distance traveled here. We knew the speeds of the bike in this case. We knew the speed of the car in this case. T was the unknown, and t is wrapped up into this expression for the distance, so that's how we were able to write the equation for t. So these kinds of problems can be tricky at first. Okay, you have to practice them, you have to work through them, but it's the same process as before. You're reading the problem, you're trying to make an equation out of it that makes sense, that satisfies what the problem is telling you, and then you just go methodically through it and solve the problems. And the very important thing in this section particularly is to know the distance is the distance, the speed is the distance over time, and manipulating that into solving for distance and solving for time, because you're going to have to write equations involving that. And so that's how you solve the problems involving distance, speed, and time.